All right, hi everybody. Welcome back to this section 4.4 video. And in this video, we're going to take a look at our first example of solving a non-homogeneous differential equation by this method of using undetermined coefficients. So here in example one, we're given the differential equation y double prime plus y prime equals minus 6 equals 12x squared plus 7x. Okay, so we want to solve the differential equation, right? And so by solving this differential equation, we need to come up with a general solution. Okay, we need to have a complementary part plus a particular part for our general solution. So remember that, you know, this portion right here, y double prime plus y prime minus 6y, that's our homogeneous component. And this 12x squared plus 7x is our non-homogeneous component. And so from this, we would get our particular solution y sub p. And from our homogeneous, we would get our homogeneous solution y sub c. So we're, we need to solve the homogeneous portion first. That's just the easiest part to do. So we'll do that in step one. So let's go ahead and get started. So solution. Okay. Solution, let me move this over here. Solution, solve this differential equation. So we'll say step one. Step one, solve the complementary solution, y sub c, using the auxiliary equation, which is from section 4.3. Okay, so we're using this method from 4.3 to solve this homogeneous part. So let's look at what the homogeneous portion of this differential equation would be. It would be y double prime plus y prime minus 6y equals 0. So this is the homogeneous part. We'll just call it HON. Or I'll capitalize it, make it a little more distinct. Homogeneous part, just the second order part right here. And so remember that, standard form for, it's like a y double prime plus b y prime plus c y equals 0. So here, a would equal 1, b would also equal 1, and c would equal -6. And so we build our auxiliary equation. And so what we would get is m squared plus m minus 6 equals 0. And so this turns into a factored m plus 3, m minus 2 equals 0. And so that means m equals -3 and m equals 2. And so here we have distinct roots. Okay, so when we have distinct roots, our solution for our complementary would just be C1 e to the -3x plus C2 e to the 2x. Okay, so that's our complementary solution. So just remember that the solution for distinct roots would be, y equals C1 e to the m1x plus C2 e to the m2x. Okay, so that is step one. All right, we got our complementary component right here. All right. Now is the part where we venture into what we haven't done yet, which is find a non-homogeneous solution using a trial particular, the point of this section. So let's check that out. So step two is going to be form a trial particular solution. So what was the function? The function was f of x equals 12x squared plus 7x. So that's the function we're working with. So a trial particular solution would be ax squared plus bx plus c. Okay, so that's my trial particular solution. And so the goal for this particular solution, I need to figure out what A, B, and C are. I'm going to need to plug into the differential equation here. So what I need to do, think back to what we first learned in this course for verifying a solution. I need to plug it into that differential equation. So I need to figure out what yp prime is and yp double prime is. So let's go ahead and get those. So pretty straightforward. The first derivative is just a quadratic, so it'd be like 2ax plus b. And then the second derivative, yp double prime, would be 2a just by itself. All right, so that's just step two, just a quick step. And here's step three is where most of our work is going to be. So step three, plug in our particular solution, oops, and its derivatives into the differential equation and solve for A, B, and C. All right, so I'm going to plug in our particular solution and its derivatives into the differential equation. Let's just rewrite it for note purposes. Okay, so I'm plugging in the particular solutions into their derivatives. So y particular double prime goes there, yp prime goes there, and then yp goes there. So let's plug them in. Let's see what happens. So we get 2a plus 2ax plus b. Let me put some parentheses here for notation purposes. Minus 6 particular, that would be ax squared plus bx plus c. And then it just all equals 12x squared plus 7x. Okay, so let's go ahead and clean this up a bit. I'm gonna have to drop some parentheses. I'm gonna make sure to distribute in this x, negative x, into this quadratic. So I would have 2a plus 2ax plus b minus 6ax squared minus 6bx minus 6c equals 12x squared plus 7x. Okay, so what I want to do now, in order to figure out what A and B are, I'm going to rearrange all of these terms to be with their respective variables. So I'm going to go x squared first, then the x's, then the constants. So I'm going to rearrange a couple of things. So what this would look like is negative ax squared plus 2ax minus bx, and now the constant's 2a plus b minus 6c. And then the right-hand side still equals the same. Okay, so I rearranged. Let me make a little note that, rearrange them. And so what I'm going to do now is factor out their variables, like x squared, x, and I'm going to kind of just group together the constants to be one constant, essentially. So what this would look like is, just negative 6a, just taking out the x squared for aesthetic purposes, so we can see what we're doing. I'm going to take out an x, so 2a minus 6b times x. And then I'm just going to group together the constants in one sort of parentheses. And so the reason I'm doing this is a method of equating coefficients. So now we're going to equate coefficients. And this is such a great algebra principle that we can use to our advantage, is that since the left-hand side is x squared x and a constant equals some right-hand side of x squared x and some constant, we can equate their coefficients. So it's really one of my favorite algebraic principles. So let's look at this first one. So in this first x squared, we have, negative 6a x squared equals 12x squared. Well, we have x squared equals x squared, so what we can really do is just equate their coefficients. So negative 6a equals 12. And so a just equals negative 2. All right, so let's look at the next one. Let's look at just x. So we have 2a minus 6b x equals 7x. All right, so this just means that we can equate their coefficients. So 2a minus 6b equals 7. So I already know what a is. So I could plug that in there. So this is 2 times negative 2 minus 6b equals 7. And so, negative 4 minus 6b equals 7. And so b would just equal negative 11 over 6. Okay, not the prettiest number, but that's what b would be. And so now let's look at our last coefficient. That's c. So call it step 3. We have 2a plus b minus 6c, and we don't have a coefficient or a constant term on the right-hand side, so it's just going to be 0 as a placeholder. So that makes it a little easier for us. So this just equals 0. And we already know what a and b are. So this would be 2 times negative 2 plus negative 11 over 6 minus 6c equals 0. And I'm going to fast track some of the algebra there, but what we end up with is negative 35 over 36. Okay, so yeah, not the prettiest numbers for B and C, but hey, like that's what they are. It's not the prettiest problem, but we get our coefficients that were undetermined. So let's call this step 4. Step 4, plugging into our particular solution. So step 4, plug A, B, and C into our particular solution. So our particular solution that we started out with was just ax squared plus bx plus c. And so we have what a, b, and c are. A equals negative 2, B equals negative 11 over 6. C equals negative 35 over 36. So we'll just plug these in. And so our particular solution is negative 2x squared minus 11 over 6x minus 35 over 36. And that's our particular solution. So putting this all together for our final general solution, so our general solution, remember it's uh, y equals our homogeneous plus our particular solutions. So our general solution would be C1 e to the negative 3x. Or let's write down what, backtracking a bit, what our complementary is. C1 e to the negative 3x plus C2 e to the 2x. Getting that from all the way back up here. That's our complementary. And so particular solution is just up above. Okay, so if we put this all together, y is C1 e to the negative 3x plus C2 e to the 2x minus 2x squared minus 11 over 6x minus 35 over 36. And that is our solution. Okay, so like I was saying, quite a bit of work. Most of the work is in steps 2 and 3, right? Finding the particular solution, your trial, and then trying to figure out what A, B, and C are. Steps 1 is something we've done before with the auxiliary equation, and 4 and 5 are just plugging in and getting our solutions. So long questions, we're going to get into some long differential equation solutions. So take your time, make sure you're doing it right, and we'll try out some more. All right. So thank you for watching, and I'll see you in the next video. Okay, take care.